Welcome back to Stationeers and part 2 of our airlock self-build guide, whatever we end up calling this. Yes, it's us basically reproducing the default of the airlock and hopefully improving it a little bit by adding some kind of custom pressure level. Also, maybe doing other things like having 2 different atmospheres on either side of it rather than, say, vacuum and then whatever we put inside here. So if we had this as an airlock into, say, a hydroponics bay, you could do that. But to start, we need to build in the simplest parts. So last episode, just as a brief summary, we got this so that whichever button we hit, the doors are going to shut. Doesn't matter if one's shut, one's open, which way around they are, doesn't matter. It will shut them both anyway. And it will keep them shut. If you try to open, if I'd press this button, okay, and accidentally, let's say it's partway through pressurizing, you open one, it's going to shut it again. So I guess you can get out really quickly and escape with some air, but you know, you shouldn't really want to. Let me just reset that for a second. Reset you and reset you. Something else will reset these once we have the rest of it working. So and then we also have the airlock state. So depending on which button you actually push, let me just open this for a second. Depending on which button you actually push, we'll change this value. So if we push this one, it's going to change to 1. And if we push this one, it's going to change to 2. And of course, the door's going to shut again. So I need to reset this once more. So then we need to do something with those. So the first thing we need to know in order to start depressurization or repressurization is, are the doors shut? And right now, we don't have any direct way of doing it because we don't have something that combines both the states of these doors. We do have if the outer door is open and if the inner door is open, and they're both currently 0, i.e. they're both shut. So we want to test whether both of these are actually 0. So to do that, we can add them together and compare them to 0, of course. So that's a simple way of doing it. So let's go ahead and look at that. I guess the easiest thing to do is for me to put down a math unit. So let's just grab you. And I've got a space here that I wasn't using for anything else. I guess I could have space at the other end as well if I rearrange some stuff. But for now, let's just... yeah, logic math should do us. So let's just rotate you. Actually, it doesn't matter the rotation this particular point, but that's... straightforward. So again, we can say what's our input. So we want inner door open and outer door open, and we want to add them. So I can just click on through those. Inner door open and outer door open. That's a bit further along in the list. There we go. And we can turn you on. So it's currently adding up to 0, which is fine, which is exactly what we want. And we also have a memory chip here called 0, so we can do a comparison saying, you know, whatever this is. So we can say, I don't know, both doors open. And I'm saying both doors open because of the 0 and 1. Not that I actually ever want the both doors to be open, of course, because it's an airlock, except when it's depressurized, but that's something else. So both doors open, no, which is exactly what we want. So now I need to compare somewhere to say, all right, so does that equal 0? And I'm probably going to have to start using this wall and then the ceiling and then probably some other bits and pieces. And of course, this is all using power, so I've just exposed this so I can turn it off. So let me just build that next part. Okay, so here we are. We have a compare unit, and what we're doing is taking the both doors open math unit, and we're comparing it to 0. And of course, we've got 0 up here. So this is currently 0. Because one door is open, and it should be 0 if this one's open as well. But if I shut both, it changes to 1. So this is our safety. We don't want to do anything involving gases unless this is actually 1. So this is both doors shut. Makes sense, hopefully. Well, then I'm going to need to add a couple more... Oh, I'm going to need some more maths processors, I think. Are you still making me cable coil even though you're really slow at it? Yeah, you are. Okay, I'll put one in and then I'll do the rest off camera. So we're going to be able to... We're going to need to know what the airlock is actually requesting, what the users are requesting. So this state we're going to have to translate back from 0, 1, 2, 3, 4, 5, whatever we want to put in here, the states back into zeros and ones. Now, you could get a bit sneaky here and think, well, this is, this is 1 and this is 2, so maybe if I just subtract, I don't know, 1 from this both doors open thing, or from here, as soon as this changes into 1, I can subtract 1, it turns into 0 and 1, and you can translate, don't go that way. That way lies madness. And also, there's a problem there, because as soon as this changes back to 0, then it doesn't change the state. So instead of 0 and 1, you'll get 1 and 2, so one of those is still incorrect. So don't worry about it, just leave it separately. And we're going to add some compare units. So instead, we already have, and I changed this first switch. Remember back at the start of the first episode, I changed this to be a sort of implicit thing based on this state. So if this goes to 1, I was storing 1 because that's what this is when you push it. Instead, I changed it to the same as the inner button. And so I have these values, I pressurize and I depressurize. So I depressurize was the one thing I used to get implicitly from just pushing the button and it changing to 1, but I've actually got an actual number here now. So we want to use that actual number, and we can then compare it to whatever the current state is, so the airlock state. So we can drop in a compare unit, and I think that's hooked up at the moment. So we can then say we want to compare. Let's go for depressurize first because it was the first one that I clicked on. I depressurize equals and then airlock state. I think. Yes. Turn it on. So currently it's 0. So is our airlock state equal to 1? No, you aren't. So if we close that door and we push this button, it should change to 2, so it should still be invalid. Good. And now if I just reset this just to the default, and I open a door, not that the door matters for this particular circuit, but if I now say I want to depressurize, I want to head outside, this changes to 1. So as soon as both of these are 1, you can add them together and compare them to 2 or something along those lines, or take them away from each other and compare them to 0 because we already have 0 as a memory unit. Would that work? So if this is 0, it would value it to 1. If this is 0, no, you can't take them away from each other. No, because if they're both 0, that causes the same result. So we're going to have to compare them to 2. We're going to add them both together, compare them to 2, and if that's true, then we can trigger whatever it is, the depressurization sequence, which probably means, and I think to keep this simple, at least for this second part, what I'm probably going to do is have 2 active vents. One that's permanently set to outward and one that's permanently set to inward, and we'll just switch them on. Because then we just have to deal with 0s and 1s, and it's easier to understand which one's which. Because if this one is currently, if that's set inward, it's currently set to outward, which means it's going to push air that way. So this is the depressurization. So let's just actually change this to pressurization vent. And we can create another one for the pressurization vent. All right, so let me go and tell my machine to make more math units because I'm going to need them. And I guess we can just, yeah, you're still there. I need to reset you again. Reset you again. I should probably make a reset button while I'm constructing this, but we can just turn the power off as well just to save on power while we're constructing this thing. Of course, we will need a power saving device of some kind because this is far, far too much electronics to keep on all the time. But that's okay. Let's carry on and put some more compare units in. Okay, so we've got this extra compare unit now, and it's doing exactly the opposite. Well, not exactly the opposite. It's comparing I pressurized to 0, or to airlock state even. So if I instead hit this button, I want to pressurize, the door's shut, 1, and this is also 1, and if I just change this back again to 0, you'll see that no longer is true, even though both doors are shut. And of course we can just reset this again. Okay, so we've got these 2 things that we're now going to use to control pressurizing and depressurizing. To control that, we're going to need to do something else with them. We're going to need to combine them with both this one and this one together, and this one and this one together. I don't think we can combine them all into one thing again, so, well, at least not that we want to at the moment. So I've also added a memory block that says 2, and it's status 2, and then we can, of course, add these together with a math unit, and add these together with a math unit, and then we can use that exact, we can use another couple of compares, and whatever those compares output is what we want to send to the 2 vents. So let me just put those down. Okay, so I've added another vent. I've called this one pressurization vent, this one depressurization vent, and of course I probably want to put these to the sides or something like that in an actual setup, but just for demonstration purposes I'll put them right next to each other. So we've got 2 compare units, and if I just turn those on, they should be 0 and 0 at the moment. So if I actually, which one do I want to do? So I want to depressurize. If I hit this button, this should turn to 1 only when both doors are shut. So wait for it. There we go. So at that point we can start depressurization. And similarly, this one would only turn to 1. If I, for example, now press this, that's going to turn to 0. This one's going to turn to 1. So it's going to, what we're going to do is read in both of these values and just apply them to these vents. Quite simple, at least to start with. There's no shut-off valve for that yet. There's no way to stop this from depressurizing or pressurizing. But, you know, baby steps. Let's get this out of the way first. Okay, so let's see if it works. Let's turn these on. Alright, and everything should be reset at the moment. It is your reset, your reset. So if I'm pressurized at the moment, I want to depressurize. I'm going to hit this button. Door should shut. And we should get a vent coming on. There we go. So this one is currently set to outward, so it's going to depressurize us. So all the air, you know, if we had air in here, will be being sucked out of this and being pushed into this room. If I push this button, on the other hand, that should shut off, and the other one should come on. And then it's going to continue. There's a problem at the moment in that doesn't ever shut off. So it's going to pressurize this to whatever value we set. So I guess one of the things we could do, and that'd be an interesting experiment actually, if I just request to shut doors and reset this state for a second, they should go off. Yeah, because I passed through the state, it corrected slightly. That doesn't matter for this particular case. So what we could do is look at writing what setting to use for this pressurization. Instead of doing it and balancing it with gas sensors, we could just define a custom level. And that may be something that's worthwhile just reading in first of all to see what it's currently set to. I'm hoping that it's set in units of, well, either kPa or PA. If I set a memory unit down, the only problem is if it's something like PA, it's going to be a little bit tough to set. It's going to take a lot of clicking. But I could set it to 2 kPa with that kind of thing if we wanted to. And we could see how well that does. So let me just, did I reset everything? Yeah, I did. Let me go and grab a couple more pieces, well, a few more wires, and we'll see if we can set it to a defined level, and then maybe we can test this. I just want to make sure I don't necessarily depressurize. I don't want that door to ever open, but I don't think we have manual open. I don't think we have automatic opening at the moment, so that's probably okay. Let me just grab some bits. Okay, so I've put a piece of logic memory here with a pressure setting of 20. I took a look at this pressurization vent with a reader, and unfortunately looked at the wiki, and there's not much in the way of documentation for this vent. There's a couple of settings we can use, and let's just, this is off at the moment, so we can take a look. The setting, and its default is 100. So I'm assuming that's the 100 kPa. I hope it's that. If it's not, then of course we'll find out. Let's go through. Pressure external is 0 at the moment. We're in vacuum, so I assume this is on the external of the vent. Internal is over 1 million. So again, I'm not sure if that's indicating pressure in the pipe. Do I have my tablet on me? I don't. Let me just go and grab my tablet to see what's in that pipe. I doubt that, to be honest, though. I expect that pipe to be in vacuum. Are you there? Are you powered? Good, you are. Let's just pop downstairs. What's in that vent? Nothing. So we may have to deal with the pressure internal. That's one possibility. But let's go with setting to start off with. That'd be useful. It could also be that setting means percentage. You know, you have to go all the way to that pressure internal value. I hope not, because that pressure internal value is way, way higher than I want to actually edit. I'd have to probably take this and multiply it up using another block, which I don't want to do, but let's give it a go anyway. So pressure internal, I guess what you could think of it as, if its setting is 100 kPa, if setting was 10, if that was a percentage, that would be 10%. So you could do it in percentages quite easily. It's only if you wanted a specific setting. So let's change that back to setting, shall we? So pressurization vent setting, we're going to write in from this pressure setting, which is here. All right, so I guess now would be a good point to shut this door. And see if all my other doors are shut. Yes, they are. Okay, so we now have our atmospheric storage system running. I'm going to move away just because it's quite noisy. And we're going to head in here. And will it depressurize, I wonder? Let's pop this. And it's pressurizing. I've got these buttons set the wrong way. Well done for those of you who spotted it. And we are depressurizing. Good, good, good. And let's see if we can pressurize. So it's going to flip over. I'm going to pressurize. So this is currently set to 20. So either it's going to pressurize to 20 or 20% of maximum. Or it's just going to ignore it and just keep on pressurizing. So setting is probably useless. It's probably not setting we're looking for. And of course, we should probably think about depressurizing or something. Let's just flip this back again, shall we? There we go. So we can certainly pressurize and depressurize. I've just got to figure out what's going on with these two. What can we actually set to make them stop? Hopefully stop automatically, rather than me need to do a gas sensor thing. If we need a gas sensor, then we need a gas sensor. But if they could do it automatically, that would be cool. Probably not, but hey, let's give it a go. And for the eagle-eyed among you, yes, I did need to turn on the logic writer, but it still didn't help anyway. The same thing happened. So pressure internal, pressure external, and, well, I guess we could try pressure internal. I don't think I've tried that yet. Let's just give that a go. Let's turn off this system, by the way. Flip it around. There we go. Will it actually do anything if I set this really low, like 20? Will it actually switch anything off? If not, we're going to have to use a gas sensor. That's going to be next episode if we do. So let's just push the pressure depressurization. All right, so we're down to 0. And let's pressurize, please. Let's see what happens. Well, that's definitely not shutting off. So we're going to have to design the shut-off system as well. That is, of course, unless any of you guys know is different. And if you do, leave the comments down below. Because I'm more than happy to hear the comments and adjust this design if I need to. Especially if I've done anything stupid. So we've certainly got a pressurization and depressurization system going on. Next episode, we just have to deal with shut-off. Before we get there, though, however, I thought I just would address one thing, and that is, let me just actually reset this just start resetting the system. Let me just flip you over. Yes, so if you want to build a large airlock and you want to massively increase the speed that this pressurizes or depressurizes, remember I was saying you could have just lots and lots of these? There's something, if you're going to build that you need to know. You'd be tempted to take these and replace them with logic writers, but of course now you can't. And you can't do that because logic writers will write every instance of one type in your entire network. So if you set them to write to active vents, they will write any active vent in this room because it's all on a subnetwork. So you're either going to have one logic writer per vent, or you're going to have to create 2 subnetworks. So if I had logic vents on this side and logic vents on this side, I'd have to have a batch writer on the inside of those. So, you know, inside of the APC, right into all of them. And that batch writer would pull in from a piece of memory that's like this, with the inside of the APC on this side and the outside on this side. And then all we need to do is pass that value. So instead of a compare, well, we could take a compare. Yeah, we'd still have these writers, but instead of writing to the vents, they'd write to these memory modules. And on the inside of the network, we'd have batch writers. Now, I'm not going to need that, but if you decide to do that, it's a straightforward modification. It just means a bit of extra electronics if you want to do it. The alternative is you then have a batch writer, but instead of writing to on-off, you could write to the state. So the whether it's set outward or set inward. So that would be its mode. And that's the other way you could do it. That's probably a simpler way, but it's up to you entirely which way you do it if you decide to have many vents. Okay, so I hope you've enjoyed this episode. There has been some atmosphere in here for a change. Next episode, we're going to deal with shutdown conditions and also how to balance it. So what we'll probably have is some kind of gas sensor on the inside. And that means whatever you pressurize the inside to, even if it's only 20, we should be able to say, well, if the one on the inside matches this one, then it's okay. And then we'll look at other things like, well, what do we have to do if we have two different atmospheres? We'll have to have two separate sets of electronics, and it could get a bit more complicated. So we'll see. I don't think we can do that in one episode. So we'll see about that one going forward. Okay, so I hope you enjoyed this one. Feel free to give it a thumbs up if you have, and of course share, subscribe, like, whatever, etc. More than happy to hear any of your comments. So that's the main thing. I do enjoy user interaction. Thanks for watching. We'll see you next time.